Why, hello there. We're doing limits, and this is part one of many in the limit series. It will just be a handful of examples where they will all be sort of different. And here we go. All right, so here we are, and we are finding a limit of this little function here. And the first thing you would probably try to do is substitute this value 1 in here. So let's try that. Let's try it and see what happens. So we'll try to substitute. That should always be the first thing you at least try. Now, I think you can eyeball test this and know that it's not going to work out very well. But if I substitute 1 in for this, we're going to get 3 minus 3 on top, 1 minus 1 on the bottom, which is 0 over 0. And that is completely undefined, and that's not what we want. So we can't necessarily say that this function is undefined. Okay? So what we want to do is one of two things. Either graph it on the calculator, which is a last resort, or to try to grind this thing down a little bit with algebra. So let's try that first. So if I say the limit as x goes to 1, approaches 1, I'll show you what that means with the graph here in a second. And we take the top and we factor out a 3. We will see that that's x minus 1 over x minus 1. And notice I put parentheses around the bottom because I'm trying to show you that this cancels that. And so this whole thing here would equal 3. So on top, this would equal 3. Now, does the limit as x approaches 1 equal 3? So in other words, does the limit as x approaches 1 equal 3 of f of x? Okay, where this is f of x. Let me write that a little bit neater. I got a little bit out of whack there. Does the limit of that equal 3? Well, let's look at the graph, because we know if we plug 1 into this, it's undefined. So at some point, there's a hole in this graph. And if you plug this in your calculator, just put that in parentheses over that in parentheses, you will get basically a line that looks like this. So it's going to go up 3, and it's going to come across like that. And then at 1, right here, where x equals 1, it's going to have a little hole in it right there. And it will keep going this way. So that's basically what the graph looks like. So we have an issue here. As x approaches 1, we'll say from the left side, as it approaches 1 from the left side, this value gets closer and closer to 3. In fact, any number other than 1 itself, gives you 3. I'm going to pause this. I want you to graph it and try this. All right, so we see that this has a limit. As x approaches 1, it will have a y value of 3 or something approaching 3. If you put directly 1 into this, it's going to be undefined at that point. So we could express this as the following. F of x equals, so this function here equals 3 when x is not equal to 1. That would be a correct statement to say there. The function equals 3 when x is not 1. It is undefined when x equals 1. So that satisfies all the numbers there. When it's anything but 1, the function output, or the f of x, equals 3. And when it is 1, it is undefined. So we could say that the limit as x approaches 1, both from the left and from the right, this is called a left-hand limit right here, a left-hand limit. More on that later, though. This is called a right-hand limit. This would be approaches 1 from the positive direction and 1 from the negative direction. but it has to do it from both sides. So this would technically have, I'll just write it out here. It's minus 1. This would equal 3. 3. A legitimate 3 would, because it approaches from this way, stuff like 1.0001 and more, and this is like 0.9999. If you plug that in there, you would see that it would equal something very, very close to 3. And that's basically the concept of a limit. See ya.